Well, hello, everybody. Welcome to episode 28. Is that right? 28. Good Lord.
I think that's right. I think
Right.
that's right.
So, our shows are averaging 30 minutes to an hour. So we have almost a full, complete day of programming for you at this point. So that's great. Today we have Michael Fulbright joining us, and Michael will be talking about the INDI driver. We have, of course, Jerry Hubbell and Kent Marts here, as well as myself, Scott Roberts, and we'll also be talking about ST4 connections and Bob Hoskins Exos 2 tuning techniques. But let's get started with Michael today. Michael, how are you, man?
Mute.
You're muted.
Sorry about
We
that.
do
It's
that to
good to be here,
everybody.
Scott.
Yeah,
Thank
we
you.
That's
tell
a
them
test.
muted,
We do that.
they forget to unmute. So, but that's cool. So, thanks for joining us. This afternoon, and we've got a nice audience watching this right now. So we're simulcasting on YouTube, Twitch, Twitter, and Facebook.
Okay.
And we have who's with us. We got Dan Janisic, who's almost always with us. Nico from Argentina. James, the astrophotographer. Dustin Haskins. Wolfgang from Germany's watching. Tim Myers. Tim, I can't remember where you're calling or watching from. And then Ansel Puri, who's from Los Angeles. John Adler is with us, so that's very cool. But greetings, everybody, and we're going to get started with talking about the INDI driver. And Michael Fulbright is the author in the OpenGOTO community of the INDI driver that will allow you to control the PMC8 with your Mac and maybe also like a Linux machine. Is that right?
Yeah, Linux, BSD, and Macs. Yeah, pretty much.
Awesome. So I think we have, Jerry, do you have your screen you can pull up with his presentation?
I can pull it up.
Oh, can you pull it up? Okay.
Yeah, he's got it on his.
If you want to get started, let me try that.
All right. Unless there's some opening remarks that you wanted to make, but
Is that showing up?
it looks beautiful. Look at that.
Great. Okay. I got to get my version.
Yeah.
Okay. So if you want, I'll get started.
Yeah, go ahead.
All right. Thanks, Scott.
Excellent.
And thanks, Jerry, and everyone else. So
Sure.
yeah, I wrote a driver for INDI for the PMC8 mounts, and I'll go through and talk about what INDI is and how you use it. And do y'all do questions during the talk, or do you wait to the end?
Either way, if you prefer, we wait to the end, I'll read them at the end. But if you're okay with us interrupting, then I'll.
That would be great. Just flag me down. I'll get talking, and you'll have to stop me, but that'll be great.
No problem. No problem.
All right. So I'll start discussing INDI. I'll let you read what it stands for. It's kind of a mouthful, and I don't think anyone ever uses it, but it's sort of a description of what the project is about. INDI itself is a protocol, which in computer speak, that's just the way computers talk to each other. So they defined a protocol for computers to control instruments. That could be a camera, focuser, a mount. A lot of the early use of INDI was in professional observatories. So they talk in terms of instruments. Most of us think in terms of hardware. So using that protocol, you set up what's called an INDI server, and that runs on a computer next to the telescope. And it handles requests from other computers and other programs to talk to the camera, the mount, focuser, filter wheel, etc. So if you think about it, it's kind of what ASCOM does under Windows. And ASCOM traditionally has been a Windows-only solution. So INDI was kind of the response to have a solution that worked on any type of computer. So once you get your INDI server running at the telescope, you can run what is called client software. And that could be a planetarium program, could be imaging software. And those can actually run on any other computer. It doesn't have to be on the same computer. And you could have it in your house with your telescope out in the backyard, or you could run a telescope on the other side of the planet using it. So that's kind of what INDI is. I'll discuss the project a little. So it's called an open source project. And primarily that means the source code, which is what you use to write programs on computers, is available for anyone to use and modify. And that part is important. Up to this point, there's been over 100 contributors to INDI. These are people like me around the world who have downloaded the source code, added a feature, fixed a few bugs, and then sent the fixes back to the project, and they've incorporated it. So that way you have a big community of people working on the project. It's no single company or person is in control of INDI, so it kind of has a life of its own. You may have heard of Linux or Apache. Firefox is a web browser. These are all open source projects you might have heard of. So this is just another one. INDI is cross-platform. That just means it's an open standard. It can run on Macs. It can run on Linux. BSD is a Unix-like operating system. Some people have worked on it for Windows. There's really no limitation. And it works on little computers like a Raspberry Pi, which is not much bigger than a credit card, or it can work on, your biggest desktop machine you want to run on. So it's kind of can run on anything. It's a nice feature. And finally, I mentioned it earlier, but it's distributed, meaning you don't have to run the client software and the server connected to the hardware on the same computer in the same location. And lots of people have used that to run multiple telescopes simultaneously. So any questions about INDI and open source?
Right now,
All right.
Not yet.
Okay, good. So I borrowed this from the INDI site, but up here we have a computer. I guess it's called localhost or ECOS. This computer is running a program called ECOS that I'll discuss in a minute. It lets you control a telescope and camera, kind of like Sequence Generator Pro or Voyager, some of the common software you may have heard, Nina. And then down here at the bottom, we have two Raspberry Pis connected to a mount and a DLSR. This one's connected to a focuser and a CCD. So this one computer here can control all this hardware at the bottom through these Raspberry Pis, which could be connected by Wi-Fi somewhere else in your yard or in the world. So that's what they mean when they say it has distributed control. And you may have seen an ASI Air or a StellarMate. These are small computers you can buy and attach to your telescope and run them with a smartphone or tablet. That's kind of the idea here. So who works on INDI? Well, it's mostly people like me. It's about, I think there's been 120 people commit so far code to the project. And they're mostly volunteers. I don't know if anyone works on it full time yet, but the source code is on a server on the internet that anyone can download it from and work on it, fix it. For example, I had been talking with Jerry and I was like, let me work on a driver. Once I got it working, I sent it to the project. They looked through it, made sure it met their standards. And after a few fixes, we got it included in the project. Now, not anyone can add code to the project. That would be kind of reckless. So you have to submit it to the project for review, but they're generally pretty happy to get any contributions. And as I mentioned before, since no one company or person controls it, it's not like one day they can decide to just quit supporting INDI and it would just go away. So if the people working on it decided to do something else, I'm sure other people would be interested in picking up and continue working on it. So it'll kind of have a life of its own. So to get INDI, primarily people using INDI right now are using Linux, but Macs are starting to become more popular. For Linux, if you're running that, they have binary packages that you just download and install for most of the major Linux distributions. That would be Red Hat, SUSE, Ubuntu, etc. There's tons of them. Just pick your favorite. They make stable builds and nightly builds. A stable build would mean it's been tested and run for a while. It's pretty reliable. Nightly builds are right hot off the presses. Every night, there's an automated system that takes the current version of the project, builds packages, and puts them out. So you can get the latest features that way, but you might get the latest hiccups as well. So generally, people start with stable builds, and then once you get to know the nightly build system, you can start trying the new features out.
Mm-hmm.
Yes. Was there a question?
No, not yet. Not yet.
Okay,
No.
with you. I heard
I was just acknowledging your.
Yeah,
Sorry to.
the nightlies are for the
right.
courageous. There's also a binary version for OS X. I guess that would be Max.
Yeah.
It's for K-Stars, which is a planetarium program, but as part of that package, you can get INDI.
Hey, Michael.
Yeah.
When you say binary download, what does that mean?
So probably what most people are used to on PCs are you download an install package that you run, and then it installs programs, which are binary. A lot of stuff in Linux, you actually download the source code and you do what's called compilation. You have source code and you build programs that you run. A binary download would have like a .exe in it, if people are familiar with that idea.
Mm-hmm.
Compared to source code, which would be a text file that you can't run until you do something to it that makes it so the computer can understand it. Source code is more human understandable computer speak compared to binary, which is ones and zeros. If you're into this sort of thing like I am, you can just download the source code and build it. And finally, INDI is being distributed in these small computers like the StellarMate and the ASI Air. Those are actually running INDI internally. And so if you bought one of these computers, you would be using INDI. And they update their software occasionally to keep up with what the INDI project is doing.
We've had customers use a lot of ASI Air customers that want to know how to connect up the PMC8, which I'm sure you'll talk about here in a little bit. But yeah, that's a typical thing that we have with our customers. They use ASIR or StellarMate too. I think I've seen a couple of customers, but that's where they're coming into the INDI driver world.
Exactly. It's like people using Android phones don't realize they're using Linux. It's kind of hidden way under there, under the hood. But somewhere down there's a Linux kernel running. So Linux is probably the most popular operating system in the world because of that. But I'm more familiar with the StellarMate because the primary maintainer of INDI started that product. And so it's pretty much coming straight off the INDI source tree. The ASI Air is running INDI, but they've packaged it in a way that's a little less accessible, so it's not clear to me exactly what it's using. They wrote a really nice layer on top of it, a front end that is a nice looking front end, especially for new users. But yeah, so I'm not sure how the PMC8 driver, if they built the PMC8 driver when they put those together, it should be there, but that's something worth investigating.
I think that's the case. I think people have used it that way. I mean, use ASI Air with the PMC8, so I know it's built in there somehow.
Cool. And this is just a picture of a StellarMate and ASI Air Pro. These are if you imagine you stack two smartphones on top of each other, that's about how big they are. They're very small computers that you can mount at your telescope, and they don't use much power.
I have a question.
Yeah,
What is the difference between using like one of these ASI Airs or the other, the all-in-one boxes versus you just buying a mini PC or a stick computer or something like that, or putting in just a Raspberry Pi? What would be the difference? Is it just that there are
yeah.
nice in a nice box with connectors and everything on it, or
I think the integration is the main thing, and you can get support. Like if you've never, a lot of us probably my age may have actually built their own computers a few times. So, you know, connecting all the parts together is kind of fun.
right?
But but some people probably just would like to have something more like an appliance that you just plug in and work.
Right.
I tend more for the put it together myself because I like to tinker with things, and
Right.
I like to pick the best hard drive and the best video, all that stuff. But
Neat.
you could,
Go ahead.
I'm sorry, you could just get a Raspberry Pi and then download an image for INDI and kind of install that on the card and boot it up, and I think that would work fine. But as I said, I think it's just convenience
Sure.
in my mind.
Well,
But
well,
yeah, it's
like
usually I tell people wanting to use INDI to this if they have a cheap laptop, because Linux runs extremely well even on old laptops. If you have an old laptop, you can just fire that up and try it on there and not have to do anything fancy. And if it doesn't work, you haven't lost anything. But
sure. Nico is asking, what language is your INDI driver written in?
it's C++, pretty much. I've written some software I use for image capture. I use Python for that, but all the INDI infrastructure, K-stars, ECOS, the things I'm going to talk about are all in C++.
Okay.
That used to be a bigger language than it is these days, but a lot of open source stuff is still in C++ and C.
We have a couple of comments here. Wolfgang is saying, I use Windows and I try not to bring my PC on the field because I have no power outside.
Mm-hmm.
Eduardo is commenting, I use the Astroberry distro.
Yep.
And the new RPI4 or RP14 and K-Stars ECOS, he says it works great.
Yep. Yeah. Astroberry is, I believe that's just the fellow who puts it together. And you basically download an image, and the Pi uses a little card, kind of like you put in your camera. And you just put his image on that card, plug it into the Pi, and turn it on. Hook up your hardware, and you're ready to go. You need to be a little technically savvy to do some of those steps, but there's a lot of people doing it. It's pretty neat. So that's cool. I'm glad to see people are using that.
Yeah, cool.
All right. I'm about done. Let me just get going here. So I'll talk a little about the client software, which would be the programs you would use. You don't really ever see INDI or the INDI server. That's kind of something that runs under the hood. Now, K-stars and ECOS are the primary programs people use. K-stars is a planetarium program. I don't know if you've used Stellarium or Cartes du Ciel, the sky, I think. There's a lot of planetariums you use. They show you the night sky. You can pick any time and date, and it'll show you where comets, stars, everything are. So that's what K-stars does. ECOS is the imaging part. It handles cameras, filter wheels. I kind of list the features here, but it'll essentially, if you think of Sequence Generator Pro, it kind of is doing very similar things. You set up, I want to take this many exposures of this object. Please autofocus and use plate solving to find the target and center it. So it handles all that stuff for you. And those are open source projects as well. And I just have a screenshot here of K-stars. I picked a random part of the sky. You can see here's Orion. Here's Taurus, Auriga. And K-Stars is kind of neat. You can set it to download an image of the sky from some internet servers. I think this is using a NASA server. But you can see Barnard's Loop here in Orion. Here's the Pleiades. No, they're not on here. These are probably a flaming nebula up in Auriga. And as you zoom in and zoom out and scroll around, it just loads the sky. Of course, it shows you the planets. Here's the comet everyone's excited about. There's a little red cross. I have a simulated PMC-8 telescope running, so it's simulated pointing at the comet. It has a neat feature where you can ask it what's up at night. So you go over here and you can click on, say, comets. This is just a picture, so I can't do it, and it'll show you the comets that are up at that time. So it's like most planetary programs. There's some other client software, Cartes du Ciel, Stellarium, work with INDI. There's a nice planetarium I don't see a lot of people use, but HN Sky is another one. It's kind of does its own things. I use it sometimes.
I've used that in the past.
It's a neat little program. PhD2 for guiding. If you're taking images, CCD Seal is by the author of Cartes du Ciel. It's an imaging program. And then I mentioned the StellarMate and the ASIR are also using that client software. So late 2016, a friend of mine and I talked with Jerry and Scott about the OpenGOTO, and they were getting started then, starting to develop a mount for the G11 and the control system. And that kind of fits in with my interest in open source and INDI. So I started working on a driver that December, and in January 2017, they accepted the driver. Hard to believe that was 3 years ago. But
yeah, I know. That's
Jerry and I just talked on the phone afterwards, and he was working on the ASCOM driver, and we were kind of comparing notes, and we kind of worked out a way to do pulse guiding, which is you can use a cable called an ST4 cable, I think Scott mentioned that earlier, to control the mount for guiding. Basically, as your mount tracks, it needs a little updates occasionally to stay on the target. And you can either use a cable, an ST4 port to do it, or you can use pulse guiding. And people like having both available. So we talked about how to do it, and he implemented it for ASCOM, and I added it to the INDI driver.
Actually, I want to give Michael some more credit, because we did the prototype on the INDI driver before I implemented it in the ASCOM driver to get it working. And so we figured out the method. We figured out the methodology. Remember, we went back and forth between the move command and other commands.
Well, that tends to happen when you make your protocol and your source code available. People who are interested, more creative than I am, will go out there and use it in ways you could never have imagined. So that's really good y'all have done this.
So Michael, we talked about the ST4 port pulse guiding. Do you run the guide camera then through your Mac or your Linux box and then out to the PMC-8 box? Or are you using the legacy ST4 port? Or how are you doing that?
Right. So let's say a lot of people are using PhD2 for guiding these days. And PhD2 connects to your guide camera and is continuously taking pictures and following a star that you select. And if that star looks like it's drifting, it tells the mount how to move to put the star back where it's supposed to be. It's kind of like laser guiding. If ST4, you tell PhD2 about your ST4 port, and then PhD2 will send commands to the ST4 port through the cable to the PMC-8 controller, which then will make the corrected move. If you're using pulse guiding, you don't have a cable involved at all, and PhD2 will send the request to the mount, the PMC-8 mount driver, in this case ASCOM or INDI. So it's more of a software way to control the mount that doesn't involve the cable at all, which is
right. The cable, the ST4 cable, it's a legacy connection. It simulates the contact closure from your camera relay output, and they're using MOSFETs today But in the
Right.
original design, it was a contact closure, just like a standard old manual north, south, east, west paddle is what it started out as. So
That's true. Yeah.
that's the signals that were going through the cable from the camera. So it's a hardware, like Michael said, is a hardware solution where the pulse guiding is more of a software solution.
But how does it get from the guide camera into the PMC-8 mount if you're not using an ST4 cable?
Well, in that case, the only thing the guide camera is responsible for is sending images to PHD2, and then PHD2 sends the commands to the PMC-8
through the
USB connection.
Right. That's what I was trying to get at.
Okay. Yeah. So, like I said,
Like-
it's one less cable.
Action, right?
Right.
Yeah.
There's a specific ASCOM and INDI command. Like in ASCOM, there's a pulse guide method that you call to update the position or to send and then that gets translated in our ASCOM driver to a PMC-8 command to move the mount that tiny little bit necessary to get it back on target. And the same thing with the INDI driver.
So on the if we're using a PC, we're using an FTDI chipset serial cable USB into the PMC-8 box.
But
if we're using like my MacBook Air, we're just going to use a straight USB to USB or USB to the input on the box to control the driver or control the mount. Correct?
That sounds right. Yes.
Okay.
Yeah. Like I said, it's essentially you just get rid of an extra cable, which is kind of nice.
That is
because there's a lot of cables if you're imaging. So.
right.
There are some indications it might be a little more responsive to do it in software, but I don't know if that's as important. Since I committed the original code, I don't have the names here, but there have been several people who've worked on enhancements. When they've added other mounts with PMC-8 controllers, you have to change a gear ratio so the mount tracks at the right speed and the slews will go to the right place. So those are pretty easy changes. And then people have added things like auto-detecting the mount type and other things. So that's kind of how open source is supposed to work. I kind of got the ball rolling. Other people can contribute and push it a little more up the hill. And in the end, you end up with a nice solution that everyone did together.
Michael, can you tell how many INDI drivers have been downloaded? Is that information available to you?
No, I don't know easy way. There's so many places you can get it. Each Linux distribution builds it and includes it in the Linux distribution, and then people download the source code. I don't know a single metric for that, but
so this INDI driver source code that you created for the PMC-8 is included in all the operating system downloads. Is that what you're saying? In terms of the packages for the INDI package and also for other distributions, it includes the INDI stuff. So it could be thousands and thousands of people have downloaded it. It's just that they don't use it. It's available for use. I think
that's the case. I mean, the INDI forums are fairly active. I don't know how many people are on there at any given time, but I mean, it's certainly not going to be like ASCOM because Windows is still kind of the primary platform for astronomy. But things like INDI are sort of giving people options, especially people with Macs. I know a few Mac owners who were a little chagrined they had to go out and buy a cheap Windows laptop just so they could use their equipment. So I think there is interest.
Yeah.
Now, one neat thing about INDI I've always liked is that kind of at the core of INDI is joystick support. And if you plug in a joystick, which is like a little gamepad or a wireless controller on your PC, it'll let you control anything. I mean, you could control your focuser with it. I don't know how you'd use it. I guess you could change filters with it, but the thing I use it for is a hand controller for the mount when I'm imaging a planet. It always drifts out of the center, and it's always nice to have a little thing with switches on it. So that's something I didn't even have to implement. That was part of that. I kind of got that for free.
That's nice.
So,
on the Windows, on the ASCOM, there's something similar in the EQ mod project, ASCOM driver. It's the ASCOM pad, pad, and we've got customers that use that.
That's the same idea. It's a good way to handle it. So now with the help of these other people, I think, pretty much anything you'd want to do with a PMC-8 mount, slew, park, guide, all those things are supported now. So
Have you gotten much feedback on things that, I mean, you rang it out pretty good when you first released it, and it's been pretty stable, I think, most people are pretty happy with it. Isn't that the case?
Yeah. I tried it out last week, just give it a, I haven't been doing as much imaging as I'd like, but I built it and everything just worked out of the box. So it detected my G11. Everything was just great. So
how hard is it to set up the joystick? Is it just plug and play, or is it?
Let me try switching. I actually have a computer running the simulators here. Oh, I don't know how well this will show up, so let me switch to it.
Go full screen here.
Can y'all see that well enough, or?
Yeah, it's a little soft, but we can see it.
All right. I'm not sure. Yeah, I don't want to tinker too much with this setup, but
fine.
Let me switch over to my copy and I'll show you. So this is called the INDI control panel, and it is where you set up everything. It's kind of like the ASCOM configuration. So here you would control tracking. You can park and unpark. Somewhere, I think it's options. Yeah, I don't know if you can see, it says joystick right here.
Yes.
And if you hit enable, then if you have a joystick plugged in, then it'll start using the joystick. So like I said, I didn't have to do anything.
Now when you say joystick and plugged in, are you talking about like a game controller? Or?
Yeah, like on my PC, I have a Logitech gamepad I use for video games.
Okay.
It's wireless, which is nice because I can use it at the telescope without another cable. Any way to get rid of another cable.
Sure.
But any cheap USB controller will work. This page, you set up things like your telescope aperture, your focal length. It uses all this stuff to figure out your field of view if you're imaging. Here you pick your mount type, and you can connect with a serial cable, or it says Ethernet, but you can use Wi-Fi here if you want to. So you set all that up. And then right now I just have these other devices. They're all just simulators. There's a simulator for the guider, CCD, focuser, and the filter wheel. That way you can test all your equipment out during the daytime. You don't need to go out.
Very cool.
So this is about all you have to set up when you want to get things started with the PMC-8. And then I'll show behind there is, I don't know if you can see it, hopefully. This is K-stars. I'm scrolling out. It's loading the image of the sky in real time. You can see California Nebula up here. Here's the Pleiades, M45.
Right.
So it's kind of handy. It's neat to be able to see where you're looking at. You can do this. What's interesting, I showed that earlier, but here I can actually click on like Comet, and then here's the one everyone's interested in right now, NeoWise. Have you guys looked at it yet?
Oh yeah.
Yeah. But you can also pick, let's see what galaxies are up. So this is a nice one. It's much smaller though, so you got to zoom in to see it. But here it is loading that image in real time. So it's a neat little planetarium program.
Well, what's is your INDI driver. It really adds a lot of flexibility to controlling the PMC-8, and it looks like your whole ecosystem of other equipment and everything under one platform. So that's yeah.
They've been working at this
now
for a while.
Let's say that you're excited about this. Let's say you are a Mac user and you want to get started, but you really don't know how to compile code, okay, and you've never done it before. These are more advanced kind of ways to control the telescope. What are good baby steps for someone to take? Is there someone that can mentor them, or is there are there enough people on the OpenGOTO community who have done this? You could say, okay, yeah,
Yeah.
this, and you're gonna be set.
I'll give some links at the end that will link you to the INDI site.
Okay.
And there's a link to what you would download. And as you said, that's only the first part, is getting the software, then how to use it.
Right.
Also on that INDI site is they have forums they have like a user forum. They have one for developers, etc. So that is a good place to go and ask questions about how to use INDI and K-stars. Those would be my first suggestions, is just check out what the INDI site offers. But certainly if we have enough people in the OpenGOTO community using it, that would be another thing you could leverage. I know there's a few, I know people have contributed code, so people are using it. It's just, once you get it working, maybe, it's always the case, you see people on cloudy nights and things always, generally you see the people who are having a problem complaining about something. You don't see the 99% of the people everything's working for. So I would start there. As I said before, I've only used it with Linux. I think once the software is installed on the Mac, it's going to look the same as what I'm showing you here and act the same. It's just getting it initially installed and configured would be the trick.
All right. We do have some questions here and some comments.
Great. Yeah.
Let's see. Find out where we were. Dustin Gibson from OPT is watching, so gave him a shout out. Thank you for watching. Let's see. And Eduardo Simone has a comment. It says, same with Linux to PMC8, just need to reprogram the FTDI chip to invert the DTR signal. I'm not sure what he's...
I didn't want to get into all the details, but there's a little, you just make a slight modification to the USB serial cable. You do it it's documented on the website. It only takes a few minutes, but yeah, if you don't do that step, it is a little frustrating because probably won't work. So
that's a software. There's a utility that is provided by FTDI to do that. It's pretty straightforward procedure, but you have to be technically oriented a little bit to do it.
Mm-hmm.
Yeah.
So could you just buy a regular USB cable and go on down the road then, and not use that cable?
I think you have to make this change. I remember with the
this change is needed.
I had to do something similar.
Yeah, this change is needed.
It works.
Right. This change is, we don't have to get into the details, but it deals with the way the system is, the way I designed the system, and the way Linux uses the serial port, the way it's configured. That's all it is.
Okay.
So you can't just use any old serial cable or USB cable?
No, it's still got to be an FTDI chip cable, just like always.
Okay.
Yeah.
Okay.
And I would recommend that in general. Those are going to give you less trouble, typically. I've found. I always use FTDI cables, but yeah.
Got another question here. Tim Myers is asking whether using a Pi type solution or a mini PC, is there a good place to pick up custom length USB cables to keep the wiring methods clean on your mount and scope?
Oh, there's a place I've used. I can't remember it right now. I think it's the L-com. I'm not endorsing anyone. I'm just, there are some places that make custom cables if you go out there and look. But I generally just buy from the big vendor everyone else probably buys from online and just wrap it up in a Velcro cable to get the right length. But I would recommend getting ones that have a right angle connector on the end.
Mm-hmm.
You're less likely to break the connector out of the back of your camera or your mount if you have a right angle connector at that end. So I would definitely, if you're going to replace a cable, I would look for that.
One thing to keep in mind if you're looking for custom length cables is that the adapter, the serial to the FTDI chip adapter that I suggest is built by Parallax, which we know is reliable because that's who built our chip in the processor in the PMC8. But that's a separate cable from the adapter, so you can so you can plug in different length cables. But it's not like these all-in-one adapter cables that are all, potted with with plastic around the actual electronics. It's not like that. It's a separate piece. So that's something to consider also if you're looking for a custom length cable.
Yeah, that gives you more flexibility for sure.
James, the astrophotographer, is asking, and I think you already answered this, but can you download Linux on an older Windows PC to run this for a dedicated field PC? I think the answer is yes.
Yeah, so traditionally you would download an ISO image. You don't have to get into that, but basically you download an image, you would put it on a big thumb drive.
Mm-hmm.
You would boot from that thumb drive, and then you could install Linux in parallel with Windows. It doesn't run under Windows. It's a separate operating system that boots up and everything.
Okay.
So you would have what's called a dual boot computer. You could pick Windows or Linux. Some people have tried using a virtual machine. You may have heard of VMware.
Yeah.
It lets you run, basically simulate an entire computer underneath the hood of Windows. So you could try booting that in a virtual simulator under Windows, but since it is simulating a computer, sometimes things like USB and other things have quirks. I wouldn't do that just because I don't think it would be reliable, but that's why I was suggesting if you have an old laptop, or like me, I go find old off-leaf laptops. If you go on eBay, you can see someone who is just unloading 5-year-old computers for $100 each, and
Wow.
that's what I use.
Yeah.
Because I'm going to leave it outside anyway. I'm not going to put a new expensive laptop outdoors. So
That's right.
yeah.
Okay.
Some people do get a Raspberry Pi and try it that way. My only caution on the Pi is it's not a PC. It's amazing technology. It's very power savvy, but it's not the fastest thing in the world. So most of this stuff works all right, but a PC is going to just be a nicer user experience. It's faster, has more disk space.
All right, that's kind of what I've been struggling with these single board computer systems. Is the performance is not quite there yet. Although the next version of the Raspberry Pi may get there finally, but again, that's what you'll see. You'll see a difference between a laptop and one of these single board computers.
But like I said, the 4 is still an amazing piece of equipment, and depending on your use case, it may work, and they're cheap to play with. But like I said, you can find used laptops for. Once you get a Pi and the card and the power supply and the USB, once you add all that up, you probably spent $60.
Mm-hmm.
I just get cheap laptops.
Better.
But they both work.
Chris Moses wants to know if you can run it with the new Linux subsystem for Windows.
Don't know about that. I know about the subsystem. I'm probably the only person in the world who hasn't used Windows 10, so I don't know much about that stuff. But I think that is working at a little bit higher level to run software. I don't know if it implements some of the low-level parts that you would need to talk to things, but it'd be nice if that would be one option for people to try it out, but I don't know.
Interesting. And then Redbeard on Twitch is saying, I've been leaving my XPS 13 outside for years and everything's still okay. So.
Yeah, I generally put a towel over it to keep the dew off, and if it's really cold, I'll put a blanket over it, and that seems to, the heat the laptop generates seems to be enough to keep it happy. So, but I wouldn't do it with an expensive laptop.
Right.
I've been lucky. I've never left anything out in the rain, but it is outdoors. It could be kind of hostile.
That's right.
I know where you are, you can have thunderstorms blow up in no time, and it's kind of that way here.
I think we'll take it out, so.
Yeah.
Right?
Yeah.
Certainly.
I really like Mr. Thump Study's comment, good place for cables, Radio Shack.
Oh,
wait. Yeah. We actually have a Radio Shack here still. It's open.
There's some Radio Shacks out there. Not very many, but.
There's a small town about an hour west of here. It's basically a town on the road, and there is a very old Radio Shack. I keep wanting to go in there just to see what they have. But
Right.
A whole wall of diodes and stuff.
Yeah.
Oh man, that was a go-to place for all the components you wanted to
Yeah.
experiment with and play with, and it crushed me when my local one, because you can't. There's really no place to get a good source. Sometimes you can find something at Walmart or at Best Buy, but again, it's so few and far between. You don't know what you'll find in terms of just cables.
Go online to Fry's Electronics. They probably have.
Well, yeah, DigiKeys is where I go to now when I want to order anything. DigiKey.
Right.
Or Mouser.
Yep. I just had one more quick thing to show, and I'll be finishing up here. There's not any more questions or comments.
Go ahead. There's not been anything
All right.
pop up.
Yeah, let me just roll this out. So here, this window is the ECOS window. This is the one you use for imaging. The page I'm showing you right now is kind of the dashboard.
Okay.
It shows that we're tracking. It shows my target. If you were focusing, it would show the focus sequence here. And down here, it would show you, if I was guiding, it would show you a graph of how well your guiding's working. So generally, you leave it on this page once you get your project running.
How accurate is the autofocus? Trusted all the time accurate or monitor?
Well, I mean, it basically it does an autofocus, and then you start imaging, and then if you switch filters, or I usually set it up every hour to refocus. So it tends to do a good job. You know, it's comparable to, like I said, Sequence Generator Pro or some of these other projects. So you don't have to go outside with your hand and squint and try to focus. You know, it's all handled by the computer. This page is where you would set up, you would tell it your target and the coordinates, and then you would say, I want this many exposures and this filter, or if you're using DLSR, use this gain or ISO. And it'll slew to the target. It'll use plate solving, which is, it takes a picture of the sky, it finds the stars, and makes sure they're in the right places. If they're shifted from where you want to be, it tells the mount to move again. It keeps doing that. Usually takes 1 or 2 tries, and you can get within a few arc seconds of your target. Once it's plate solved, yeah, go ahead.
No, that's just
Once it's plate solved, it will focus and turn on the guider, and then just start taking images. When you reach the zenith, if you have a German equatorial mount, you have to flip, or you'll run into the mount will run into the tripod. It'll handle all that for you, and then just keep imaging on the other side. So all of that's what ECOS handles. This is the mount page. You can do kind of neat things. You can tell it to like auto park the mount at 3 a.m. every day. So if you want to just set it up and go to bed, and then when it's all done, park the mount so you don't have to worry about anything. It'll do that.
nice.
You can park it. You can control tracking. There's a mount control where you can slew it around with this virtual hand pad. You can put in coordinates and have it go there.
Do you know if there's a scripting language in this, to write scripts for doing this automation?
No, and that's kind of why I ended up writing my own stuff in Python to do that.
Okay.
If you were very technically oriented, yes, you could probably do it, but there's nothing like CCD, what is it, CCD Commander, I think, is a nice Windows program. I don't know if it's supported anymore, but you could write a script basically to tell it. I know Voyager has a scripting language.
Yeah, I'm familiar with the MaximDL scripting language.
Yes, I know what you're
That
saying.
you can automate stuff with that too.
Yes.
Very cool.
Here's the CCD page. You can turn on the cooler, all that kind of stuff. Focusing, plate solving, and here's the guide page. So it has a guider built in, or you can use PhD2 with it. So that's ECO.
There's a question that's come up.
Mm-hmm.
Does the autofocus use HFR or what method? Any idea?
Yeah, so
HFD is a half flux diameter versus a full width at half maximum.
Yeah.
It's just a way to measure the profile.
I think it uses HFR, which is half of HFD. But you know, there's stuff's changing all the time. I thought someone had added a few other. I guess not yet. Maybe I'm using a stable build, so I'm not using the nightly, which has all the cool stuff. But I think it's using HF. It says right here HFR on this axis here. So, and you can set it up to use a star that you pick. It'll pick a star by itself, or it'll use stars across the entire image. Which, you know, if you have a telescope that has a little bit of field curvature, that's a nice compromise to try to keep the center and the edges focused, is using the entire field. So I think that's what SGP does. I think Voyager and Nina do something similar. So that's kind of ECOS, and I'm going to switch back over to the presentation here, and let's see here. I'll show you the links, and I'll leave that up on the screen. So if you want to show that to people later.
All right.
These are some links to some of the software I've talked about. I forgot to mention ASTAP. That's a plate solve, open source plate solve program that's getting a lot of interest these days by the same author as HM Sky. It's a really clever fellow. So
does that, do you know if ASTAP uses the astrometry.net code?
No, I think he got bored and just wrote something.
Wrote his own?
It is very fast. Oh, I have a pretty modest laptop, let's say 2015 model. Generally, it'll solve in less than a second. It is, and it can do blind solving also, not as quickly, but it's. I've started using that instead of plate solve too with Nina. But there's a lot of nice options out there. That's the nice thing about this. So thanks again for having me. I can hang around, answer questions or whatever.
Just a couple other comments here, and I know that you have to go you had some family things you had to get to, which is it's great that you were able to spend some time with us, but families are...
Yeah, I got about 10 minutes. If you want some comments and things, I'll hang around.
Yeah, but Red Beer was talking about, this is a continuation of the commentary that was going on. He said, used it for ham radio stuff before I got into astrophotography. It interfaces with my portable command center and Pelican rocket case with LG ultra wide and lid on lift struts. 180 amp hours of, oh, he's talking about a battery.
Oh, okay. You lost me.
I see. This is for power. There is a gentleman watching on YouTube from Sandia National Laboratory, Albuquerque, Scientific Research and Development, the Thermal Test Complex. He said, thank you. So that's very cool.
That sounds like a fun job.
Yeah.
I spent a summer in Los Alamos when I was a grad student, so I've been in that part of the country. It's beautiful out there.
Oh, that's very cool.
Yeah.
And people liked the interface. They liked your program, and they're saying wonderful presentation. Michael, thank you so very much, and we thank you. And
thanks.
Yep, if you'd like to, if you need to drop off, you can go ahead and do that.
All right, let me just say one thing. I wrote a driver for your mount. Most of the stuff I showed you is by other people. I just want to make sure everyone understands that. I contribute, but there's a lot of people working on this. So
no, but it's very cool to know the possibilities of what you can do. You know, so that's great. A gentleman, Bob, he says, so using INDI would eliminate the need to use VNC to control the remote computer. You could just control the remote processes using the drive, ? Not sure if my question makes sense.
So yes, so I know what he's talking about. So
VNC.
Well, okay, so VNC, I don't know if people are familiar with like, what is it called? AnyDesk or TeamViewer, I think. Remote desktop. Basically, those programs let you use a computer remotely by sending you a picture of the screen, and then sending your keyboard and mouse commands back to it. Now, I still do things that way because I have sort of spotty Wi-Fi to the outdoors.
Mm-hmm.
If you used INDI with the client server with that kind of connection, if it was time for it to download an image from the camera and it would try to send it over the network to the computer indoors. If that connection isn't fully reliable, it could potentially cause an error and slow down your capture. So I always run it so it's capturing to the computer outdoors, and then I use a viewer. But if you had a fast Ethernet connection, I think that might be a good option. But depending on the quality of your network link, you may still want to use a remote viewer.
Sure. Sure.
That's a feature of INDI. It doesn't necessarily mean I would recommend always using it in every use case. But
So you would let the computer out by the telescope do the heavy lifting and
Exactly.
manage from indoors.
Yeah. And then I have, I don't know what there's something called Sync Toy. Some of you may know rsync. Basically, it's a program that repeatedly synchronizes the drive from outdoors to indoors. I just leave that running so it's copying the images over to my computer inside, kind of in the background. So at the end of the night, the computer also has the images inside. So it works pretty well. But
Great.
all right, well, I probably will drop now if there's not any other comments. But
I think that's it.
you know, I'll be on the OpenGOTO forums. If someone has a question, I can follow up there as well. So that's a good way.
Thanks, Michael. That's great. I appreciate your time. Thank you.
Of course, guys. Thanks again.
Awesome to see. Good job.
Take care.
Goodbye.
Okay, so our next subject would be about, this should be a fairly short subject. It's the difference between the ST4 connections of the iXOS 100 versus our other mounts.
Yeah, so the initial development of the PM8 system was for the G11 and the Exos 2. That uses a large board, Model 2A is what I call it, and it's got the aluminum box external to the mount. That system, the ST4 port, was added on as an analog multiplexer system, so it requires calibration. The new iXOS
Jerry?
100.
Scott, looks like Facebook dropped off.
Well,
Oh, well, I guess we just go on without the Facebook crowd.
let's just double check something. For the rest of you guys watching right now, we're going to check our connection.
We don't have the technical difficulties display to come up, you know.
Yeah, it's possible. Sometimes we have, it's rare that we get a drop.
Oh, it's back up.
Are we back up?
Looks like it. Yep, it's back
You're
running
live
again.
now?
Yeah.
Okay.
Yeah, so did we wait for our Facebook
It's back up.
people here? Okay, well, you didn't miss anything.
Right, I'll start my
Where we were was we spent with Michael Fulbright, and if you were watching on Facebook, I'm sure that you saw the entire program. Our next subject right now is the difference between the ST4 connection on the iXOS 100 versus other mounts. And Jerry was starting to explain that, and we think we lost some of our Facebook crowd, but hopefully.
Yeah, that's a typical response to when I'm starting talking about.
Oh, really?
something.
Just people down on you?
Maybe.
That's right. You drone on endlessly about tech stuff.
Right, exactly. So the iXOS 100 and the G11 and Exos 2 mounts are a little different.
Okay.
The Exos 2 and the G11 are based on the original PMC8 design, which has the big aluminum enclosure, and it's external to the mount. The motors have cables, 2 cables going to the motors from that box. That original design used an analog multiplexer system to to do the ST4 signals out to the mount, or from the mount to the camera. And that, since it's an analog multiplexer system, I don't want to get into details of all that, but it's basically requires calibration. We do a standard calibration in the factory for that port that meets the requirements of most cameras, but some cameras are a little bit different. So it's basically the old ST4 was like a ham box that had the north, south, east, west buttons on it.
Mm-hmm.
And originally these buttons were just contacts, like relay contacts or switch contacts. So it was either open or short. And that's what the signal out to the right, exactly. It was either nothing or open, and or shorted and open. And so the box, or the camera, I should say the mount, would respond to these contact closures on each axis, north, south, east, west, to move that way as you pushed it. So to simulate that, they came up with the auto guiding system, which used relays to send those commands to the mount. It was the same as the ham box, except it was controlled by the computer or by the system. Go forward 20 years or 10 years, 20 years, and instead of switches, instead of actual relays, they use these transistor circuits to do that now. But I didn't do that on the original design of the system. I used another way of providing contact inputs to the mount and reading them, and it requires an analog. It required a calibration to detect whether it was a short or an open. Some camera systems use transistors to provide it now, and they don't provide the same signal, and so the calibration doesn't work from the factory anymore with that camera. One of the Lodestar camera needs to be calibrated. The MGen camera system, which is a standalone auto guider, requires calibration. Typically the QHY cameras are good, and the Orion Starshoot auto guider cameras are good. But that's on the original box. The original PMC-8 was designed that way. Fast forward a couple of years, and I went ahead and I figured out a way to save some I/O ports and implemented the digital contact inputs into the IXOS 100 mount. So there is no calibration on the IXOS 100 like there is on the PMC-8 for the XOS 2 or the G11. So that's the difference between the two boxes, or between the mounts.
Okay. All right. Any questions at all? No? Doesn't look like it. Okay.
Yeah, that accomplished its purpose. I didn't. I'm surprised we still have half the numbers, the members that we have watching.
Apparently we didn't actually drop off of Facebook. You just.
Oh, okay.
It was just me.
It was
just me that dropped.
That's right.
That's good. That's very good.
That's right. Okay, and then finally, we wanted to talk about Bob Hoskins and his tuning techniques for the XOS 2. What we
Right.
What? Yeah.
Do you want to
save that?
You want to save that and just go to the prize today? Save that for next week?
We'll save it for next.
Or for tomorrow.
Our listeners might be wanting a prize right now.
Yeah, I think we should award a prize.
All right, so here's what you're going to win.
Over an hour.
So here's what you're going to win.
Ooh, a flashlight.
Ooh.
What it looked like? It looked like the HAL 9000, you know?
Oh, yeah.
Mm-hmm. Dave, don't.
So this is what you're going to win. This actual one
Dave,
with a battery in it.
I'm scared, Dave.
So, Jerry, what's the question?
All right, so the question is from the forum. And what I want to know is there's a recent poll that I did, and I want to see how many people responded to what basically the question is, what platform do you run Explore Stars on? And what was the percentage of people that responded that they use the iPad, the Apple iPad OS tablet? That's the question. What's the percent on the poll right now of the total people that answered, what percentage uses the Apple iPad?
Well, I don't remember. I looked at that.
I can give a hint.
It's more than 3.
It's a poll that's all the polls are done on the main forum, so that's all I'm going to say there. So you have to figure out how to find the poll.
Uh-huh.
Jerry's mean.
So how many people use the Mac environment?
No, the iPad,
The
tablet. What is the percentage of people that answered the survey use the iPad for Explore Stars?
Were you surprised by this number, Jerry?
Kind of yes and no. I knew that a lot of people wanted, because we had a lot of requests for the iPad version of Explore Stars.
Chris Moses says 100% of the masochist.
We need some Jeopardy music.
Okay, how about? No,
Oh, that's good.
not gonna do
I like that. I like that noise.
We
Just run through the menu.
So an easy way to get to the polls is to go to the home page of the group, the main group, and then scroll down, and then any of the icons that say polls, you can click on down below and go to the poll questions.
Do you want me to tell them my cheat for finding them? I just use the search function and search for polls.
Yeah, you could do that.
For poll.
Isn't that cheating?
Anything that gets you to the answer. Yeah, anything that gets you to the answer is good. It's not a cheat.
As long as it's within the rules, and there are no rules for this contest, other than you gotta be watching.
70%.
Nope.
That's not it. Mm-mm.
42 Bergman scooter.
Really darn close.
Don't say that. They have to get the exact number. It's right on the poll results.
Well,
they don't guess. They're just guessing.
He can guess, but he's still
don't guess. No, I want the exact number to point.
That's what I'm saying. To the decimal point.
45% from Redbeard.
Oh, you got to go find it.
Gotta go find it. I've given too big of a hint. James, the astrophotographer, is more than Android.
0.1.
We have.
Who said that?
James, the astrophotographer.
Photographer.
44.1%. That's right.
Congratulations.
Ooh.
So send me your James. I can't remember your name. I'm sorry. Send me your information. Service at. I know you've won another prize, but I don't. It's just not sticking in my head. So send me service at explorescientific.com. Okay. So the results are, for people who haven't looked it up, Microsoft Windows PC is 17.6. Windows tablet is 5.9.
Mm-hmm.
Android tablet is 26.5, and an Amazon Fire is 5.9. Which we had a total of about 30 people vote, which is about what we always have. I wish we had more people voting these things.
Yeah, that's about 7%, which is not too bad. 10% is good. Typically, you don't get more than 10% of the people answering surveys, I don't think.
Right. Well, the poll we have will have a contest. They have to participate in the poll, watch our show, and then get the answer.
Yeah. Yeah.
Anyhow,
guys, still have to pet the is.
You have any? You guys have any more to add to the show before we sign off?
No, I think it was a good show. I appreciate Michael
Yeah.
coming on and
Yeah, it was great
sharing.
to have him on. I was really impressed with the way that the power of the Indie driver and all those programs out there. And I mean, it just opens up a whole world for people that run Linux or Mac or, you know,
Mm-hmm.
or even
Mm-hmm.
Hey,
Windows machine.
hey
Yeah,
Scott, why don't we copy those off that slide and pin those to the top of the comments or at the top of the video on YouTube? That would be a good way to get that information up there for people to
I've
see.
I've got the PDF file that he sent me of the presentation. I can send you. That might help. We'll have to. I'm sure he wouldn't mind sharing it.
Yeah.
yeah. Okay. All right, gentlemen. Well, thank you very much. And thanks everybody that was watching. And we'll be back tomorrow with more. We're going to, at least one of the subjects is going to be Bob Hoskins with the Exos 2 tuning. So if you have anything that you'd like to see in future shows, please let us know. You can email us at service@explorescientific.com, and we're happy to entertain any kind of subject.
You can post it to the forum too. If you have ideas, start a topic, say I'd like to see this on the OpenGOTO Explore Alliance broadcast.
We do look at the forum every day. So thanks very much, everyone, and we will see you mañana. Take care. Bye-bye.
Bye.